All right, today's the day, the dreaded vocab day. So we're going to spend all day today talking about some vocab and different terms, and some of these you know and some of them you may not know, and that's okay. We'll go through them. You may want to pause and go ahead and write down all these definitions or at least paraphrase them so they're in your notes. What we're going to do is talk about characteristics of parabolas today. Some things that we want to be able to do is know the correct vocabulary after we do today. So I'm going to go ahead and read through them fairly quickly. We'll talk a little bit about them, but I really want to get into the examples and you can see the way we're going to set these up. So the vertex shouldn't be new. It's the point at which a function is going to reach its maximum or minimum value. Axis of symmetry is a line that divides the figure or graph into two equal parts. Domain is the x values. Range is all the y values. The end behavior describes where the graph starts and ends, and basically what y values it starts and ends. The maximum value is the highest possible y value that we can have. Where we have the minimum, it's going to be the lowest possible y value that we can have. Increasing and decreasing intervals. We're going to talk about the x values from left to right on the graph, that the graph is going up or going down, respectively. The zeros, solutions, and roots. We're going to see the same definition here. Zero, solutions, and roots is where we cross the x-axis. And then the y-intercept is where we cross the y-axis. Again, I would go ahead and pause or rewind that and pause it so you can get all those down. I know I went through them fairly quickly, but really what I want to do is to get into what the examples are going to look like here. So we can start anywhere that we want. Doesn't really matter here. We'll start here. Max and min value. So when I talk about the maximum and the minimum value, I'm talking about the vertex. And does the vertex have a maximum or minimum? It doesn't show here, but we have arrows. So those arrows are going to tell us that it goes on forever. So we won't have a maximum value, but we do have a lowest possible value. If we look right here, this graph will not go down below that value. So we have a minimum value at y equals -1. Because we know that we can't go below that point. This also, if we're in talking about it, we might as well. We have that vertex, which is -1, -1. Give me that point. So we should see that the vertex and the minimum and maximum value are going to correlate there. And if you want to circle minimum, you can. We can talk about the domain. In this case, the domain is talking about the x values. So if I come over here, we have -infinity way out here. This graph is ever so slightly, as it's rising, also working its way out, also in this direction. So eventually, this graph will work its way out there, so that at -infinity, the x value, we could come up way up here and touch this graph. As I work my way across, I'll always be able to go up and touch that graph in different places. Coming over here, it's maybe a little easier. At, say, -3, we can come up, we touch the graph. -2, we touch the graph. -1, so on and so forth. So as we get larger out here at infinity, we're also going to be able to come up here and touch the graph. So our domain, we say, is -infinity to infinity. As we talk about the domain there, we also talk about the range. The range is talking about the y values. Our y values that we have, well, this graph starts high and it comes down, hits at y equals -1, and then goes back up. So we can't get any y values less than -1. So our range is -1 to infinity. Now, that's going to bring up a question, hopefully, in your mind. Why did I use parentheses here and a bracket here? Parentheses means exclusive, where a bracket means inclusive. Another way you can think of this is we cannot touch. And here, we can touch. So if I think about my domain, can I touch negative infinity? Infinity is a concept, it's an idea. It's not actually a number, so we can never touch infinity. We can always go one beyond the highest number that we can think of. So there is no biggest number out there. But if we look at our range here, we know that we can't go below -1. We can touch -1, so that's why we put the bracket here. So we can touch the -1, but we can't touch the infinity. We only use this in intervals or on intervals. So we're going to see this in our domain, in our range. We're also going to see it in our increasing and decreasing intervals. So you may want to make a note there, domain, range, and then increase, decrease intervals is where we're going to see the brackets or the parentheses. Anywhere else, our vertex, that's going to be in parentheses because it's a point. So here's interval notation. This is point notation. Next thing here, we have axis of symmetry. So we have this axis. It's going to cut our graph into half. That's going to be an equation. We have a vertical line, so that's going to be x equals -1. So we should see that x value in our vertex being the same as our x value, x equals, in our axis of symmetry with this one. Increasing and decreasing intervals. So when we talk about increasing intervals, when we talk about increasing, we're going to talk, well, where does the graph go up from left to right? So as I look at this point here and this point here, to get from this point to this point, we're coming down. And we're going to work our way down until we hit this point. From -1 on, it starts to increase. So we say our increasing interval is from -1, the x value -1, to infinity. Again, hopefully that brings up a question in your mind of why didn't I use a bracket? Because I can touch -1. I like to use a parenthesis. It is debated among the math community whether we should use a bracket or parentheses. I believe it should be a parenthesis because what do we notice at that point there? It's really not increasing or decreasing at that point. We call that a critical point as we get into calculus. And we're going to see that that's going to be a maximum or minimum value. So it's not going to be increasing or decreasing on an interval. So I like to use the parenthesis. Most people use a parenthesis, but there are a few that will allow you to use a bracket. Decreasing intervals. Here, we're going to go from left to right, so we're going from this direction. So we're going from -infinity, x value, all the way to -1. Again, I'm going to use a parenthesis because it's not increasing or decreasing at -1. It's kind of at a 0 at that point. Zeros, solutions, and roots. Here we're looking to where we cross the x-axis. So these are going to be at points. We're going to be at -2, 0, and 0, 0. I'm going to go ahead and put that for my solutions as well. So solutions, zeros, and roots all the same. Y-intercept, where we cross the x-axis, or the y-axis, sorry. So the point 0, 0. And then our end behavior. So with this book, it likes to use arrows. And our arrows, in this case, they're both pointing up. So our end behavior is up, up. And there we go. That's going to give us all of our characteristics of this graph. I'm going to do a couple more examples, and you can stick with me if you want, or you can go on your own if you think you got it. And we'll talk as we go through here. So, domain. Domain, again, we're going to have all the x values, so from -infinity to infinity. My vertex, in this case, is going to be that point there, so -2, 5. My axis of symmetry goes through that vertex. It's going to be x equals to -2. I have a maximum value this time because it doesn't go above that point. So I have a maximum at y equals, that's going to be a 5. Increasing intervals. So I'm going to be increasing. I'm going up from left to right from -infinity all the way to -2. And I'm going to decrease from -2 to infinity. Again, increasing and decreasing intervals are talking about the x values. So -2 to infinity. Notice those are correlated very closely to each other. Those values are going to be in common. 0 solutions and roots. I go through -5, 0, and 1, 0. I like to write those as points. My solutions are the same as my roots, where I cross the x-axis. My y-intercept, I'm going to go through the point 0, 3. My end behavior, I'm going down, down. So both my arrows are pointing down. And my range, that's talking about my y values. So I'm going to be able to graph anything that's below 5. So 5, oh, sorry, I have negative infinity to 5. I always want to write my lowest value first and then my highest value after. So I'm going to go from negative infinity to 5. And that's going to be all my characteristics of this graph. Here's another one. I'll run through it fairly quickly here. Domain is the x values. So I'm going to have negative infinity to infinity. My vertex is going to be that point there. So it looks like it's going to be at 1, -4. Axis symmetry goes through that vertex. In this case, it's x equals 1. I have a minimum value of y equals -4. My increasing intervals, I'm increasing, so I'm going up from 1 to infinity. I'm decreasing from negative infinity to 1. So negative infinity to 1 on the x-axis, these values are all decreasing. My zeros, I cross through -3, 0, and 5, 0. Again, my solutions are the same as my roots. So I can have 3, 0, and 5, 0. My y-intercept. Oh, this one we're going to have to estimate, aren't we? In this case, I'm going to say -3. Oh, my point 0, -3.9, maybe -3.8. Again, we're going to estimate that. And behavior, they're both ending up. And then my range, I'm going to go from -4 to infinity. So I'm going to inclusive -4 to infinity. And that's going to give you an idea of the characteristics and being able to graph or come up with those characteristics given the graph. If you have any questions, give me an email or get on a Zoom call. There you go. Go and get the words out. Good luck.